This is Senior Algebra, section 8.2. Today we are dealing with some square roots, multiplying them, dividing them, using the product and quotient rule here. So, taking a look here, the product rule, quotient rule. Remember, product means multiplication, quotient means dividing here. So, what do we do with radicals when we're multiplying, dividing here? Well, basically it says this, that when we multiply them, we can put them together or separate them. Classic example that we use is square root of 4 times the square root of 9 equals square root of 4 times 9. Now again, this is not a proof per se, but is an example of something that would work here. The left side is going to equal the right side here. So I get 6 equals 6 here. Notice when I do that, they get the same thing. When I do the quotient rule, the same thing will happen. So when I take the square root of 64 over 4 and set it equal to the square root of 64 over the square root of 4, if I simplify each side now, on the right side, well, square root of 64 is 8, square root of 4 is 2, and 8 over 2 is 4. But on the left-hand side, well, 64 divided by 4 is 16. And the square root of 16 is 4. So notice, for both the product and the quotient rule, I do get both sides to be the same. Now again, it's not a proof, it's more of an example of something that works. Okay, but it does give us a little perspective on things. Notice when I try addition here, and I'm going to use the same 4 and 9 here. When I have the square root of 4 plus the square root of 9, do I get the square root of 4 plus 9? Well, we know the square root of 13 does not equal 2 plus 3, that's 5. So addition doesn't work. And we'll take a look at addition in the next section, 8.3 actually. So on to a couple examples here to take a look at. In this one, we want to simplify it to one radical and take out as much as we can here. So look at that, the first one here, square root of 5 times the square root of 7. I combine those, I can get the square root of 35. There's nothing I can take out of 5 or 7 here. In the second one, when I combine them, I get a square root of 100, which is 10. Now, I can think of it like this, square root of 10 squared. And what happens? The square root and the squared kind of cancel each other out, right? And then in C, the last one, square root of 5, square root of 6. When I combine those, I get the square root of 30. Now, again, I would look and see, can I pull anything out? Can I rewrite it differently? So in example 2 here, now we can do a little bit more simplifying in these. So I'm going to break 20 down. Now I have a couple options. I can do 2 and 10 or 4 and 5. I am going to choose 4 and 5 for this reason. I'm going to choose perfect square roots. Meaning, taking a look, the square root of 4 is 2. So I get 2 root 5. Now, I can still get there using 2 and 20, square root of 2, square root of 10, and break 10 into the square root of 2, the square root of 5, and think of this as square root of 2 times the square root of 2 times the square root of 5. Now, what is the square root of 2 times the square root of 2? That's just 2. Okay, square root of 2 is times the square root of 2 is 4, square root of 4 is 2. So we get the same answer, just a little bit differently. In B, I'm going to break it into 9 and 8. Now, the square root of 9 is 3. The square root of 8, well, I can break that down into the square root of 4 and the square root of 2. What is the square root of 4? That's 2. So I have 3 times 2 times the square root of 2. 3 and 2 is 6, so I get 6 root 2. Now, that does suggest that I could break 72 into something different. And notice if I try a larger perfect square, 36, it breaks down easily. What's the square root of 36? 6. So I get 6 root 2. In C, sometimes it'll be beneficial to multiply them together. Sometimes you may just want to leave them broken up. So you could, some people like to put it as a square root of 96 and then break that down from there. Other people will look at this and break 8 into square root of 4, square root of 2, and break 12 into the square root of 4 and the square root of 2, or square root of 3. What's the square root of 4 times the square root of 4? That's just 4. So I get 4 root 2 times root 3, or 4 root 6. In D, the last one here, I could multiply them together, get the square root of 50. But I think it's easier to break it down. Square root of 5, square root of 2. We know that the square root of 5 times the square root of 5 is 5. So I have 5 root 2. Now, if I broke it up into 50, I could break it into 25 and 2. And again, why choose 25? Because that's a perfect square. Square root of 25 is 5, so I get 5 root 2. Same as I did before. So in example 3, now we have some quotients here. Some people will simplify, other people will break it up. In this case, I think it's good to take the square root of the top, the square root of the bottom. Square root of 25 is 5, square root of 9 is 3. Other times, like in B, it may be beneficial to simplify what's inside. 288 divided by 2, that's 144. What's the square root of 144? That's 12. And sometimes you may have to do a little bit of both. Or I have 27 over 9, that's going to be 3. And now I could do 15 divided by 3. So 15 over 3, if I put that back together, that's the square root of 5, and I get 3 root 5. Some people will think of the square root of 15 as square root of 5 times the square root of 3. And cancel out the square roots of 3. And we did that before in the last couple sections here. And then get 3 root 5. So either one was fine. And then in the last one here, what do we do with some variables? So remember, when there's nothing there, it's squared here. So I'm looking, how many a squareds do I have? So I'm going to break this up into a squared, a squared, a squared. So the square root of a squared is a for each of these. So I get a times a times a, which is a to the third. Now, the shortcut is to go, I have 6. 6 divided by 2 is 3. So I end up with, how many pairs can I take out? I could take out 3 of them. So that's where I get the a third from. In B, now a couple different variables. How many squareds, or how many times does 2 go into 8? Well, 4 times. So it's x to the 4th on the outside. Now in this one, how many times does 2 go into 3? Well, it only goes in 1 time, but I still have 1 left over. It's like my remainder here. Okay. Now, if I thought about it, if I look above here, I could break y cubed up into y squared and y. And get y times root y. The last one, z to the 13th. How many times does 2 go into 13? 6 times. And then I do have a z left inside. And then the last one, all right, now I'm doing third roots here. So the third root of 16, what times what is 16? Okay, that is a well, let's see. I can't do that. But I can do 8 here. 8 times 2. So I have a 2 on the outside. XY cubed Z on the outside. On the inside, I'm going to have, and I forgot the 2, but I should have a 2x squared y.
That's a really loud intro.
So again, pardon my mistake there. On the outside, 2xy cubed, z to the 5th. On the inside, should have a 2x